This video is Module 3. We're going through Example 1. Example 1 reads as follows. Suppose we have the following hypotheses. The null hypothesis is that pi is equal to 0.8. In context, that reads 80% of all voters will vote for Mr. Young. The alternative hypothesis reads pi is greater than 0.8, meaning more than 80% of all voters will vote for Mr. Young. And suppose we go through and we get a p-value of 0.021. P-value, of course, is what we are working on trying to understand in Module 3. So let me just kind of do a little bit of quick discussion about what we know based on this null and alternative hypothesis and that p-value. When we create a null hypothesis that says pi is equal to 0.8, if we were to then create a distribution of sample statistics using a simulator, like our Rossmann chance simulator, we know that our distribution of sample statistics, our null distribution, would be kind of mound-shaped like this, and it would be centered, it would have a mean of pi equals 0.8 because all your sample statistics would be near 0.8. We would expect to see sample statistics near 0.8. So if you went out in the world and it was true that 80% of all voters were going to vote for Mr. Young, and you went out in the world and collected a sample of voters, you would likely get a sample statistic slightly above 0.8 or slightly below 0.8. Okay, the next thing I know is that the alternative hypothesis is that pi is greater than 0.8. So, if we are going to go about finding a p-value, we would be counting statistics on the null distribution, dots on the null distribution, that are like our observed sample statistic or higher. I say that we count those like ours or higher because the definition of p-value reads that we are going to assume the null hypothesis is true and then find the probability of getting a sample statistic like ours or more extreme. And that means more extreme in the direction of the alternative hypothesis. Our alternative hypothesis is greater than, so we're going to count sample statistics like ours or higher. Now, in this particular problem, I didn't give you the sample statistic. I didn't ask you to make a null distribution or anything. I'm just telling you the p-value, but I want you to be visualizing in your brain where that p-value was gotten. How did that p-value come about? So it must be the case that we have some sample statistic that's fairly far out here in the right tail. Our sample statistic p hat must be out here in the right tail, and the sample statistics in the null distribution that are like our sample statistic or higher are only 2.1% of the sample statistics. Only 2.1% of the dots in the null distribution are like our p-hat or higher. That's what it means to say that the p-value is 0.021 in this situation. Only 2.1% of the dots are like our p-hat or higher. All right, let's try part A now. Let's first of all write down the definition of p-value so that we have it written right here in front of us. So the definition of p-value that we had stated above on the first page of the lecture guide, it reads, if we assume the null hypothesis is true, then the p-value is the probability of getting a sample statistic like ours or more extreme. And remember, more extreme means more extreme in the direction of the alternative hypothesis. So in this problem, it's just asking you to write a sentence that gives that p-value definition in this problem, but in context. Notice what it says. If we assume blank, this area here is the null hypothesis is true, but we'll have to say that in context, then the probability of getting a sample statistic like ours or more extreme, but we're going to give more details to that in the context of the problem. And the probability of that is the p-value, which we can now give because it was given to us in the problem. Okay, so I'm basically going to take this sentence and I'm going to say all that in context, in the context of this voters voting for Mr. Young and so forth. So we start with, if we assume the null hypothesis is true, I'm just going to say that in context. That would be, if we assume 80% of all voters are voting for Mr. Young. Then it reads, then the probability of getting a sample statistic like ours or more extreme. In this case, that would be, then the probability of getting a sample statistic like ours or higher, because the alternative hypothesis was higher, is 0.021 or 2.1%. Because they told us the p-value is 0.021. The probability of that actually happening is only 2.1%. Notice I didn't actually get the sample statistic given to us in this problem. So usually when you're asked to do this, you would actually give your sample statistic here. So we'll see that in later problems. Part B says, write out a contextual conclusion that we should make. And so this is us just making our actual conclusion. Do we think the null hypothesis seems more correct, or do we think the alternative hypothesis seems more correct? You're going to make a statement like, it's plausible that the null hypothesis is true, or we have strong evidence that the alternative hypothesis is true. And you're going to put that in context. So now what we're trying to understand is this p-value, this 2.1% number, giving us enough evidence against the null hypothesis that we would really say that we think the alternative hypothesis seems more accurate? And in this case, yes. Let's go back real quick to the first page. Recall here at the bottom of the first page, we had some numerical values of p-values given to us. And again, this is in your textbook, section 1.2. If you get a p-value down here between 0 and 0.01, you have very strong evidence in support of the alternative. If your p-value is between 0.01 and 0.05, that's strong evidence in support of the alternative. That's where our p-value is. Our p-value is 0.021. It's right here in this interval of strong evidence in support of the alternative hypothesis. So we can say, if we want to say it in context, that we have strong evidence that more than 80% of voters are voting for Mr. Young. So that's strong evidence in support of the alternative hypothesis. Notice I said that in context, though. Strong evidence that more than 80% of voters are voting for Mr. Young.